This is lesson 4-7, solve inequalities. Before I show you how to solve inequalities, I want you to look at this question. It says, I am thinking of a number less than 5. What number could I be thinking of? Could I be thinking of 8? So if you look here, we're going to find the number 5, okay, right here. If I'm thinking of a number less than 5, what number could it possibly be? We know that we have to look to the left of the 5 because all of these numbers down here are going to be less than 5. So the answer to this question, could I be thinking of 8? No, I cannot, because 8 would be on the right side of the number line. And that is not less than 5. That is more than 5. So in this lesson today, our essential understanding is an inequality is a mathematical sentence that contains the inequality symbol less than, greater than, less than or equal to, greater than or equal to, or not equal to. An inequality has an infinite number of numerical possibilities. So infinite means that it never ends. It could be any number and it goes on and on and on and on forever. So if we look back at this question up here, I am thinking of a number less than 5. Even though my number line ends at 0, right here, I have an arrow that's indicating at the end of this number line that this number line goes on and on and on forever. So I could actually be thinking of a number that is negative. It could be -2, it could be -1,000, it could be any number as long as it's less than 5. It could also be a fraction or a decimal. It doesn't have to be a whole number. So when we're looking at inequalities, it is important that we understand the signs that are used in inequalities. Because we have to be able to read those. So here are the signs that we use. We have a less than sign. So for example, we have 2 is less than 3. The greater than sign, 7 is greater than 4. And when I was younger and I was taught this, I was told that you think of it as like the mouth, like Pac-Man or a fish, and the mouth is eating the bigger number. We also have the sign less than or equal to. So if you look, there's a line underneath the less than. So this is indicating that it's less than or equal to. We also have greater than or equal to and not equal to. So these are all the signs that you're going to see in inequalities. So when we're looking at inequalities, we want to know how can we solve these inequalities. So we're going to be using all of those different signs to compare two expressions. So for example, we have the expression x is greater than 5. So what could a solution be to x is greater than 5? So what I'm going to do first is I'm going to find the number 5 on my number line. That is right here. Okay. And I'm going to look to see what numbers are greater than 5. I see that 6 is greater than 5. I see that 7 is greater than 5. And I have to remember this number line goes on forever. So what could one solution be? One solution could be 6 or 7 or 18.5. Those are all different solutions to x is greater than 5. That just means that this number we don't know is greater than 5. So if we plug in 6, 6 is greater than 5. 7 is greater than 5. 18.5 is greater than 5. So this number line is showing me all the possible solutions to the right of my 5 for x is greater than 5. We also need to know how to graph these. So not only are we going to be solving inequalities, we're going to be graphing them. So that means we're going to be putting them on the number line. So we're going to use the same inequality. X is greater than 5. So we go and we look for the 5, okay? And before I explain what this means, we need to go over a couple things. You have the greater than sign and the less than sign. If you see one of these signs in your expression, then you're going to use an open circle. This open circle is showing me that the number is not a solution. So 5 is not a solution because 5 is greater than 5 is not true. 5 equals 5. So you can't have 5 being greater than 5. So I'm going to use an open circle to show where that 5 is. Okay. Then the second part of this, once I find the number and I use an open circle or a closed circle, I'm going to put an arrow. And my arrow is going to be going to the right if it is greater than or equal to, and to the left if it is less than or less than and equal to. Okay, so in this expression right here, we have greater than, and I like to look at it as it's already pointing in the right direction. So I have an open circle on 5 because 5 is not a solution, and I'm making my arrow to the right. I just make it a little bit darker. If this were greater than or equal to, then this would be a closed circle. That means that the number 5 could also be a solution. So I would shade that in if it were greater than or equal to. So let's just look at a couple examples and then you guys are going to practice on your own. So down here, I have the example 3 is greater than 1. So I go on my number line, I find 3. It is a greater than sign. It does not have or equal to, so that's going to be an open circle. I put an open circle on it, and my arrow goes to the right. And I'm making my arrow the whole length of the number line. This example is 3 is greater than or equal to 1. So because it's or equal to, I used a closed circle. That means 3 could be a solution. So I put a closed circle on 3 and my arrow also goes to the right. This example, I have 2 is less than 4. So I find 2. This is an open circle. I put an open circle on it and I make my arrow go to the left because this is pointing to the left. And the last one, 3 is less than or equal to 4. I go and I find 3. It is a closed circle because it is or equal to. That means 3 is a solution as well. And I make my arrow go to the left, indicating that all of these numbers, and it goes on and on forever, all of these numbers are solutions to this inequality.